Okay, and there is a recording on the module page, which I did last year, but that one unfortunately didn't have sound, so I'm going to do a new recording today with this lecture. And let me just double check I'm having the right slides. Okay. Yeah, I think I'm having the right slides. Let's go. Okay. And so first, very quickly, and in terms of textbook we're using for this part is called the Visualization, Analysis, and Design. And that's what the cover of the book looks like. And it's written by the Professor Tamara Musna. She's from University of British Columbia, and she is a leading kind of scholar in the field of data visualization. And the university have e-copies of the book. And so the best way to get it, as I demonstrated, is actually through the reading list. And so go to the module page. Oh, it's not showing the reading list now. Okay, and go to the module page, and then on the right should be something called the reading list here. Yeah, I can still hear some noise. And if you got any questions you would like to ask, that's completely fine, but just please raise your hand first. And so I can stop and then can ask questions. Okay, and I'll go back to the demonstration. So yeah, that's the reading list on the right hand side, and it says that's the module name. And if you click, you should go to the reading list, and then that will be the first book listed there. That's one I'm going to be using for the first part. And if you just click view online, and it will direct you to where you need to type in. So for example, ask you type in the name of your organization. So type in, I think, Middlesex University. We change this again. And then next it probably ask, oh, okay, so go straight to that now. So you can see the book. And I can use this to turn the pages, etc., etc. Okay. Yeah. So that's all kind of front matter of the pages, the books. Okay, and so that's the textbook. Okay, and so today, and in terms of lecture, mostly talk about two things. And the first one, what is data visualization? And sometimes we just call it the visualization for short, or even just call Viz sometimes. And the second one is going to introducing different data types. And that's quite important in visualization, depends on the type of the data, and the visualization will be usually very different. And then after those, if we still have time, we will do a quick introduction to Tableau, which is the software we're going to use for the first coursework. Okay, and so this is the definition and given in the book, and it's quite long. We're going to break it down and give you examples or go into a bit more details of different part of this definition. And so it says visualization is a computer-based visualization system provides visual representations of data sets designed to help people carry out tasks more effectively. And so these are some simple examples most of you would have seen before, which are visualization, and like the bar chart and or line chart, things you can do and easily in the Microsoft Excel. Okay, and I just saw a question in terms about attendance. The attendance will be automatically recorded. So the Zoom will record who has been attending. And so there will no other way to record attendance. So what you will need to do is you need to make sure your name appear in the Zoom match your actual name. So then we can see that you attended, if that makes sense. Um, and I think that's the case for most of students. But I think I still see like someone and has a name shown up as Stealthy. Assume that's not a real name, unless it is. So you might want to check to make sure your name showed up as your exact name showed up. Change the name in Zoom to match your actual name. And okay, going back and to the slides. So we talk about these more simple ones, and this is the more complex ones, and it's a typical example. In the medical visualization, so they do a scan of the human brain, and you can see like a different slides as you scan through the brain. So that's also part of visualization. And there's more complex ones like this one, and we're gonna do a little bit later. So this is also an like say more advanced or complex data visualization. They're still showing data visually and try to show the patterns in the data, but it's not as common, say, as the bar chart or the line chart as you would usually see, because these kind of visualization takes much more effort to create them. Okay, and so one of the important thing in terms of visualization, data visualization, is say having a human in the loop. In the sense, this is not some data analysis uh, completely done automatically. And the reason is, say, first, some of the analysis problems are ill specified. And for example, you don't know what questions to ask. And so, for example, even in the lab last week, when we first looked at the car data set, which is a relatively simple one, but in that sense, we as a human have to find out the questions first. So once you know the exact question, sometimes the analysis can then be an automated, but just being able to find the right question to ask can be an important part or take quite a little bit of time. Okay. And this is a part where you can use the human and the visual recognition system. So basically, the main idea is when you present the data visually, we add human using our visual cognition system, which is a fancy way to say our eyes and the part of brain to processing what we saw or what we see to detect patterns. So we are good at doing certain things, and we can use that to detect patterns in the data. Okay. Alright, so and so the visualization is where you still need to be human to be involved, but to help human to make the decision faster or better, rather than say entirely replace human. And there are cases where you don't really need human involvement. You can do the decision completely using some machine learning model, for example. And so in those cases, you not necessarily need validation. I don't know. For example, there are actually lots of those used already. For example, if you're applying for a bank account or try to get a loan from the bank, and many of these cases you need to enter and use a form and you can't get the results straight away. In those cases, that it is a machine learning model or some algorithm in the backend doing the decision entirely. There's no human involved. Otherwise, it could not be that fast. Okay, and but in some other cases, you might still want a human involved. And for example, and do you want a AI judge in the sense, say, for example, do you want an algorithm to make sentences or the decisions whether a human is guilty or not? completely without any human involvement. So, or do you still want a person involved in the process? The algorithm can potentially support the judge, say providing certain things or help or information, but the final decision is still up to the user, sorry, up to the human, which is a judge in this case. And yeah, actually, can I see a show of hands? Say, if you think you are happy to have a completely AI judge, please select a tick in the participant list. And if that's not the case, please tick no, the cross. Yeah, come on, please keep going. And I think that the ticks disappears fairly quickly if you don't keep ticking it. Okay. Mm. Okay. Yeah, I think I need to find a way to stop it from disappearing. And but see, I think roughly there's still more and students selected no than the yes. That means majority of the students are not still comfortable to have a completely and decision made by the AI or an algorithm. And that is actually also the case in reality. And for example, the European Union law decides you cannot make these critical decisions by algorithm alone. That's part of the law currently. And this will be covered in more details in the ethics module. So in many cases, and especially say in government, these critical decisions currently still have to done with a human involvement, and partly because there's certain things that the algorithm cannot completely replicate yet. That's why the visualization, this is where the visualization can make a difference. Okay, and say, similar to, I guess, the other part of the data visualizations is you have a computer in the loop. And so the computer is in the loop because it can do certain things and which human cannot really do. For example, you can scale to large data sets. So if you want to create a bar chart with 10 data points, that's okay. But if you have 10,000 and if you want to do the same chart manually, that's going to take way too long. And then again, so this is examples we've shown before for these mathematical images, and it is almost impossible for human to do this manually as the data comes in, and it's not accurate, not as accurate as the computer generated graphics either. And the other important part to have a human in the, sorry, as had a computer and as part of the data visualization is it can support an interactivity. That means if a user click on the visualization itself, the visualization can change and then show different things. So in that sense, you don't have to show everything altogether, and they can depend on users' needs. They can explore certain parts of the visualization, and at that time, more details are shown. So this will be not possible if you do this manually on a paper. You cannot have this kind of interactivity. So I'm going to just spend a little bit more time to show you this example. So this is one of the more complex visualizations, has to be custom made. In the sense you can't generate in the Excel, you have to write code to create it. And so that's the actual and visualization itself. So if you, there's a link and in the slides, if you click, it goes to the website, which showing the visualization. The title is called The Great War Centuries and Centenary. So that means showing the war happened in the last 100 years. And I'm not sure if you can see, it's from the 1914 to 2014. That's when the visualization was created. And to see the visualization, you just have to scroll down the page. Okay. And so this is first an illustration of how the visualization works. And so it says, this shows the poppy flower shows number of the people died in the war, and each flower means one war, And the size of the petals or the flower itself shows how many people died. And for in this case, it says 10.5 million deaths. That's lots of people. And each of the flower is always start from, or the stem is start from the left and then tilt to the right. And this span shows how long the war is. So for this is the First World War. It started in 1914 and ended in 1918. So that's what this is. Okay, if I keep scrolling down, there should be more. Okay, and that's a little bit of background. So why do you use poppy flowers to representing people died? That's a traditional after the First World War. That was the first plant to grow on the battlefield. That's why people use the poppy flower to represent people died in the battle. Okay, and then this is the actual visualization itself. Takes slightly time to generate. Okay, yeah, and then again, so this is other thing you cannot do very easily in manually by human is this kind of animation. You can show certain parts of the visualization first and then gradually add more to it. Okay, and just because of the time, and you can I'm gonna go through try to explain the visualization quite quickly. On the x-axis is the how do I say the timeline. So that's starting from 1990, which is here, all the way to 2010, which is this end. And those are very small. You probably cannot see clearly. Let me see if I can make it slightly bigger. No, change the size of the page doesn't really make any difference. Okay, and on this side, the excuse me, and the y-axis is the duration. So higher the poppy flower, that means longer the war lasted. And as we mentioned before, that's also represented by how much this line curved from left to right. If you look at this particular flower, you can see it starts from here just before 1990, and it didn't finish until here, which is about 1920 or just before that. So that lasted almost 20 years. Okay, so I just click on it. That's why the things is changing, but it's very slow. And it's meant to show a bit more details about that particular war. And it shows actually show the name. Okay, so that's the Dervish states versus Ethiopia, and there's the two wars that was fought in I think Africa, and but this was between Britain and Italy. So it shows you the details. Say it lasts for 21 years. There's 6,000 casualties. People died. That's happened in Africa, and these are the different parties involved. So that's what I meant by the interaction. So when user click on the particular wall, and you can then show more details about it. And here the interaction is very slow. It's purely just because my computer, and I think partly because and the lecture is being recorded. That's why it's slow. Okay, and then we back. And again, just very quickly, and you can probably see these are two very big ones. One is here, and then that's one here. So this is the First World War, and this is the Second World War. And it's kind of expected. These are probably the two wars has most casualties, but there's still some other ones here which are quite big as well. If I click on one of them, hopefully it's okay. So that shows very briefly. If you not sure if you catch it, it says that's the Vietnam War. Then again, it will show a bit more information about the war itself. Yeah, that's quite slow again. So that war lasts for 10 years. So that's quite long, and had more than 2 million casualties from both sides. So certainly lots of people died in that war as well. So that's quite big in the size. Okay, and I think I'll stop there. And so this is mostly an example to demonstrate and the interactivity, and that's something you have to have the machine, otherwise the human to do is very difficult. Okay, and the next part, which is also useful, is talking about external representation and what let me. So what it does is say, and visual representation is something you can see visually, and that's external to your mind. That's what here the external means. And being able to see something itself, just being able to see the data itself can be quite powerful. And so let's just do an example. And the reason of that is because you're replacing cognition with perception. Cognition basically means here you have to have the problems or remember them in your mind and try to imagine them in your mind. Whereas you can see it and it's much easier to do just for human. That's because just how our minds work. So I have this and simple kind of information. And so we have these different points, and it says A connects to B, and B connects to C and D, C connects to E, and D also connects to E. Okay, and that's the information. So the question is, and what is the shortest distance between A and E? Let's say the distance is 1 between A and B because A connects to B directly, and the distance between A and C may be 2 because A can connect to B, and then B then connects to C. That's 2 steps. So anyone knows what is the shortest distance between A and E? No one?
3.
3? Yeah? Anyone else? Okay. I mean, this is not a particularly difficult task. It just says when you just look at the text, you have to imagine and how the connections are made in your mind. So which will take slightly longer. And but if I show you this, which is exactly the same information, the only differences are now represented visually, and you can see the shortest distance between the A and E is definitely 3. So you can either go this path or go this path. And in this case, almost everybody can and find answers almost instantly. It takes really no time. So that's the power of in terms representing cognition. You have to look and imagine these information in your mind with perception. When it's all laid out, it's very easy to see the answer. So the actual problems can be much more complex, and if you can just draw it out like this, will make it much easier. And I think that's also, for example, part of reasons why all the say the mathematicians would like a blackboard and write everything down, and that's much easier for them to look at rather than have to keep all the formulas or the deductions in their mind. Okay, and then another part is why depend on vision. So all the examples we have seen so far is to represent data visually. I mean, in theory, it's actually possible to represent data use other senses. For example, you can represent information or data using sound, or maybe feel, which is like a vibration, or even say smell. In theory, that's all possible. And but the reasons we picked it with vision or visualization, it says, and the vision systems has the highest bandwidth. So basically, that means we can processing lots of visual information very quickly. So if you think of the human eye as a computer, then the resolution is about 576 megapixels. Obviously, we're not processing all the information at the same time altogether, but that means we can have at least receive or perceive lots of and visual information at the same time. And actually, we do can and processing certain patterns very quickly. So this will be a simple example. If you look at the picture, and you probably can see the red T very quickly. and you don't even have to process, like look linearly scans through all the symbols, and you can see the red T very quickly. That's certain way because we can do this very quickly, just because the way we're processing the visual information. So as we said, it's possible to represent information using sound, but then say the bandwidth is much lower, in the sense the information you can represent at a time point is quite limited. You can't really say put and say 500 million different data information in one point. That's just definitely not possible. People will not be able to capture this. And also there's other possible and differences, for example, and the semantics of the sound is a bit different. For example, when you hear certain melodies, people might interpret differently. And finally, say it does not support something like overview. Sorry.
So I'd like to have your comment on this. So whenever we hear a sound, we always keep in mind that which device is actually getting us the sound out of it. So why is it said to be having a lower bandwidth?
No. Okay, so the question, okay, if I understand, you said if you hear sound, you can know which device the sound comes from. Is
Mm-hmm.
that what you meant?
Exactly.
Okay, so and in terms of if you want to passing on information to you, and it's not just what device the sound comes from. Actually, it's mostly about the sound itself. For example, you can use, let's say, the volume of the sound to represent one information or one kind of attributes in your data. Um, I don't know, let's say this is, say, the information about individual person, and you can have the information like, say, the age, the gender, the weight or height of the person, for example. And then you might be able to use, let's say, the volume of the sound to represent the age of the person. So maybe the louder the volume, and the older the person is.
Mm-hmm.
And then you can use other an attribute of the sound to represent other information, and you may be able to say use and the pitch of the sound. So how high or low the sound is to represent, uh, let's say the height of the person. Maybe the higher the pitch, and then the taller the person, and then lower the pitch, the shorter the person, for example. Okay, and in that sense, you can only represent two bits of information at one time. One is the age, and the one is the height. That's and if you want to add a third bit of
Mm-hmm.
information, it's already quite difficult. There's
Right.
not that many other attributes of the sound you can further manipulate to add a third attribute. Whereas, say, for example, if you use a visual channel, you can quite easily to show 10 attributes of the same person, use a bar chart or even just list as numbers. That's much easier to show. In that sense, the bandwidth is limited for the
Ok,
sound.
przepraszam najmocniej. Chciałem wysłać paszport. Czytam, jaka musi być
Thank you,
przesyłka. To
Professor.
musi być
Yeah,
przesyłka list
yeah,
wartościowych?
that's okay. Okay, and if we go back, and also I would say its overview is not supported because if you listen to a music over time, and maybe let's say each time point represents one person, and that play for 2 seconds and goes to the next person, at the end, it's quite difficult to understand, say, overall how high or how old the population of the person is in the example. Whereas if you show this visually, it's quite easy to see. And then people's experience of the sound and might be different, just depends on, say, maybe some people are more sensitive, so might think certain values is much bigger than other people think than it is when they perceive the sound. Okay. And you can also, and similar to use touch to represent an information. Again, it's quite low bandwidth in terms of how many different attributes of the information you can represent at the same time. Actually, the way of the sound touch works is quite similar to sounds. So basically, they are both waves. Then you can have the frequency of the wave and the strength of the wave. But again, that's the two main things. There's not that many other things you can use to represent. And finally, in theory, you can also use taste or smell and to represent information. But currently, we don't really have any device yet. Even you can have a way to represent data with smell, but we don't have a way to create the smells yet to show you the data. We need a physical device to do that. The equivalent of a monitor or screen, but for smell, so you can reproduce all different smells, and we just couldn't quite do that yet. Okay, so just because of the time, I'm gonna go through this part relatively quickly. And so in general, and data validation is not like mathematics. You don't have these and stricter rules you have to follow all the time, and there's clear and black or white in the sense of right or wrong. It's not that clear cut. And what you would have is something more like the guidelines. So there will be something like for this type of data or this type of tasks, what will be the best way to design the validation? And that's the most common ones. And these are called idioms. So these are just the guidelines based on people's experience and current knowledge about how best to design a validation, but they are not like, say, very strict rules. And then the other terms is quite useful, we're gonna use a lot, is something called visual encoding. So that basically just means how do you turn the data to a visual form? So turn a data, which is abstract, which are say numbers or text or letters, into visual attributes or visual elements, like say the size, the color, the shape, etc. So that's the term, or the process is called visual encoding. And so then this module, or at least the first part of the module, is mainly just to get you to understand this process and teach you some of the commonly known guidelines or the idioms. So these are the general guidelines that you should follow. Usually it would lead to a good visual design. And just equivalently, there's interaction idioms as well. So these are the ones, the guidelines when you designed interactive visualization, the one we saw before. And we probably wouldn't have that much time for the interaction part, so mostly focus on relatively static visualization. Okay, and also, and very importantly, is to focus on the task and the effectiveness. And so first depends on what task is, and the visualization itself could be different. And then the other one is to measure how good a visualization is, which also it will be the criteria how we measure your coursework is depends on how effective the visualization is, and not depends on how fancy or how complex the visualization is. So if a visualization can support the particular task, so that means in the sense if people look at the visualization, they can easily find the answers they're looking for, then that is a good visualization. Doesn't matter which is and how complex or how beautiful the visualization is, so long as it can help people find the answer quickly, that is a good visualization. And then again, depends on the task, as we mentioned before. Say the visualization work for one task might not work for the other. Okay, and so let's say this is a simple example, and here the task is to find out which section of the data has the largest value. So we can represent this as pie chart. I assume most of you would have seen pie chart before. And so here we're doing the pie chart, and we represent each data as a color. So the say the black one maybe show the first value, the red one is the second value, and then the yellow one the third value, and so on. And we have three sets, so we have three pie charts. And then, so the question is, for each of these circles, and which color is the largest? That represents which value is the largest. And again, okay, and now instead of click yes and no because and the tick or cross because it disappears quite quickly, so we're gonna just ask you to raise your hand, which is, oh, okay. Maybe you can create a poll. Let me see if we can do this quickly. Polling, add a question. Just give me a minute. Let me see if I can add poll question. Which color has the largest portion? And let's do black. Red. Or how do I put this? Beige. Okay, I have to have beige one. Yellow. Okay, and so if we look at, let's just go back to my slides. Yeah. So if we look at the first one, and can everyone pick out of these 3 sections? So 1, 2, 3, 4, 5. So that's with the black, red, beige 1, yellow, and beige 2. Which one do you think has the largest value? And I'm not sure if you can, I mean, oh, actually, can I also ask, can you see the results on my screen?
No.
Oh, okay. Okay. Yeah. So we have quite a few votes already. I give you maybe 5 more seconds. I don't know exactly where you can find the poll, but then I'm gonna just do a screen capture, and so you can see it.
Once you tap on the screen, it appears on the top of the one.
Okay. Okay, and I'm gonna just do a screen capture now. And let me find the actual picture so you can see the results. Yeah, this one you can see, right?
Yes.
Yeah,
Yes.
okay. And so that's the results from the first poll. Okay, and so that's one way to represent it. So about 70% people picked the black one. Let me just move the other thing around. And then some people picked the red, and some people beige. Okay, so it's quite a, I guess maybe there's a bit of confusion between the black and this part. That's maybe the most where people get confused. The 2 most likely options, and all these are the 2, and are fine. Obviously not. Okay, so in terms of the visualization, maybe the pie chart, and somehow it's quite popular. And we can do the same for the other 2 as well, but just because of time, I'm gonna skip that. And then a different way to represent is just using bar chart, equally simple, probably even simpler than this. And this is what represents show you, and this one. And so you can easily see that, say the black one has the largest value. And in this case, I don't think anyone would pick any other values. and we probably can do this faster than we're using the pie chart as well. So this is the example saying, in this case, and the bar chart is a better representation than the pie chart because it makes it much easier to find the answer compared to this one, even faster, and say people are probably more likely to be accurate. Okay. Okay. Let's see. I mean, we can do the similar experiment for the second and third one. I think this is probably the hardest one, the middle one. And because the difference is really small between the different colors, so maybe more people will get even more confused. That's why in this case, the bar chart is a better choice for visualization. Okay. Yeah. And then, so before we finish up, we just want to discuss one more thing is about limitations. And there's limitations in terms of what visualization can be achieved. And these are limited by different factors. So the first is the computation limit. Basically, how powerful your computer is used to generate a visualization. Just because, say, the processing speed, the memory, and there's only a certain amount of data a computer can process. And then the second limitation is the display. So it depends on how big a display you have. And it limits how much information you can display. Okay, for example, if you have a big display like this, it's like entire wall, you can display lots of information. And if you only have a phone, and what you can display will be much smaller. Okay, can I have a quick question? Say, in theory, what is the maximum number of information you can display on a screen? Anyone want to have a guess?
So could you repeat the question, please?
The question is say, and in theory, what is the maximum number of, say, data points you can display on a screen?
Is it the number of pixels on the screen?
Yeah, so I think someone said that already. So the maximum one you can display in theory is you display one data point as one pixel on your screen. One pixel just means one dot on your screen. And if you heard of, say, screen resolution, say 1092 times 8, say 1080, that just means the number of pixels. But obviously, and that's not necessarily a very good one because you display each data as a point, but you might not be able to see much out of these patterns. You just see kind of like a white noise screen, which might not be very informative. And so that comes to the last limit, which is how much human can see and understand at the same time. And so this is actually quite low. And for example, you can show something like this to a human, this one in the bottom right corner, and you can see that there's lots of information there in terms of lots of different dots. But we as a human, all we can really get from the visualization is say, oh, there's lots of dots. They're all very connected. And that's about as much as we can say. We cannot say exactly how many are there, or is there any particular patterns between the connections. That is usually beyond our limit of understanding what is in the data. Okay, so that's why, and so usually, and the computation is the least limit, and the display limit may be the second one, and the human is the most limiting factors. So we as human can only see about maybe a few hundred or even maximum 1,000 data points at the same time. And anything beyond that, we just can lose the ability to understand what's in the data visually. So that's again something you probably want to keep in mind. And so, and if you have something, say more, you have 1 million data points in your data collections, and how do you display those? And usually that's when the interaction will come in. So you want to show some an simplified view first, and allow user to see more details when the user say, for example, select certain parts or items in your visualization, and you can display more details. Okay, and we're going to cover that a little bit later. Okay, and that's all we want to cover in terms of what is visualization. So it involves both human and computers, and we want to use visual channel or our eyes to see the patterns because it's fast and it can process lots of data. And there's some other limitations of how much the visualization can do. It cannot solve all the problems for sure. And also there's things like, for example, and a good visualization is one which actually helps you to solve the problems quickly and accurately. It's not about how fancy or how complex the visualization is, not like how many colors or do you use 3D, etc. Okay, and the next one, we're going to just introduce different data types. And that's very important is because depends on the type of data, the visualization will be very different. For example, and if you have a table, like Excel spreadsheet, you have the data, that's mostly numbers, compared to you have a, let's say, text or maybe a map, then the way to display these informations is very different. Okay, so first we just want to introduce different types of data, and just a little bit of warning, and this part can get fairly complex. Okay, and so first we're going to introduce in data types, and so based on the book we have the 5 types, and the first one is the attribute. And so if we look at, say, individual, so this can just, if you imagine you have a spreadsheet, let's say these are spreadsheet of the products in a supermarket, and then the columns or the attributes of the data is the first data type. So these can be, for example, the price and the weight, the name of the product. So these are the attributes. And then the items. The items are the rows. So a different, say, the bread, egg, beer. Each of these are each one row in the spreadsheet, and these are the items. And then the link, which is different type of data, and it only happens in a network type of thing. So you still have the items. In this case now is represented as nodes, and then you have connections between them. So that's the different one, and which is treated as a new data type. And there's grids, and that's for 3D shapes. For example, if you remember, for the grid, we saw this 3D scan of the human brain a little bit early on as examples. So that's the example of grid. And finally, we have position. So the position essentially is mostly for map. Then you have the position of the data, and you can show them on the map. Okay. And then we have different data sets. So these are, so data are the individual data points, and the data sets are a collection of data points or data items. And then we have 4 basic types. Okay, and the first one is table, probably the most common one. So just think of it as an Excel spreadsheet or a CSV file, and it's made of, say, items and attributes. That's the most common one. And then it's networks, so it looks like this. An example would called social networks. So it's made of items and links. So the items are the nodes, which is the same as the item here, but you have the links. And then we have the fields, which is made of grid. Again, think of these as 3D human brain models. And this is something we will not be able to cover too much in the module. And then finally, we have the geometry. Essentially, just think of it as something with shape. And the typical example will be the map. Then you have the shape of this is UK, and the position of certain points inside. So these are the 4 main dataset types. So mostly we're going to just focus on the table because that's the most common one. We will cover a little bit about networks and geometry. We will not have time to cover fields because actually fields is usually used and covered in a separate module or topic, which is called the computer graphics. And that's where the fields is used the most. Okay, and finally, we're going to introducing something called attribute types. If you're not completely confused already, so attribute itself is one of the data types. So if you remember here, say when we talk about different data types, we had attributes as the first one. So think of, say, the price of a product or the name of a product. These are the attributes. And attribute itself can have different types because it's very important. So it's got treated differently and you have different attribute types. And the first one is called categorical. And the second one is called ordered. And within ordered, you can further have ordinal and quantitative. Okay, so we're going to start with categorical. And the categorical attribute does not have an implicitly ordering. That means there's no ordering between the values of the value for the attribute. Examples including name, for example, or say you can, the name is mostly made up of letters, and there's no ordering. You can't really say this name is before the other name or the other way around. And the other example is shape. So you can have different shapes. So this is a cross, this is a circle, and this is square and triangle. There's no particular order. Say triangle should be before the circle or the other way around. There's no inherent ordering between the values, make it categorical. But for names, it can potentially have a hierarchical structure. So these are different concepts, say entity, including both abstract entity and concrete entity. And between, under concrete entity, you can also have physical objects, processes, time, and location, etc., etc. You can potentially have those. And the important things to know is you can distinguish between two things, whether they are same or different. That's all you can do. You can say the two names are the same or different, or two shapes are the same or different. That's all you can do. You can't say which one is front or which one is first or which one is bigger or smaller. And you could give it an order, but this by impose something onto it. For example, and you can potentially order the names alphabetically. Say I always start with A. That's not the natural order, but it's something you can do possibly. Okay, so that's the categorical data, or categorical attributes, I should say. And then these ordered attributes, and by the name, you probably guessed, these are the attributes which you can have order. And then within ordered, I have ordinal and quantitative. And so in terms of ordinal, that means you can have an order between the different values, but you cannot do any computation. So the example here, typical example given is the dress size. So you can have the small size, medium size, and large size of a t-shirt. So the three sizes is ordered because you can certainly say the medium is larger than the smaller, and the larger is even larger than the medium. So there's order between them, either from small to big or big to small. But you cannot do any computations. You cannot say, I can take a small size and then plus the medium size, it will give me larger or something in between. That doesn't make much sense in reality. So that's called ordinal. And finally, you have the quantitative. Again, so those are probably the most common ones. And these are numbers usually. So you can apply the calculation. And so you can have age, distance, weight, all these attributes. You can not only have an order, but also you can say, okay, this person is 5 years old, and in 3 years' time, he will be or she will be 8 years old. So 5 plus 3 equal to 8. So these are called quantitative ones. Okay, and they might have slightly different names, but these are the 3 main types. And the categorical one, which you can't order, and there's ordinal one, which you can order but cannot compute, and finally the quantitative ones, which you can do different computation. Okay, and then a little bit summary in terms of what we covered today. We'll first talk about what is data visualization. It's try to augment or improve or help human capability rather than say improve human. So the human is still in the loop. And then we're using external representation by showing the data. We replace cognition with perception. So you don't have to remember and imagine what data is like. You can just see it. Even just this can be very useful, make the task much easier. And we choose visual systems instead of say sound or smell or touch, is because the visual systems had higher bandwidth and processing much faster in our brain. Okay, and then say a good visualization is one that helps you to solve the problems quickly and accurately. It's not about how fancy or how colorful or how beautiful the visualization is. It's about, does it get the job done? That's the most important thing. Okay. And then finally, and the visualization itself cannot solve all the problems, especially very large data sets. A data problem with lots of data items, and it's limited by how much the computer can process, and how much you can display, and then finally how much we as human can see. So the last one is the most limiting factor in the sense we as a human can only see say a few hundred at a time. So even you can process and display much more. For example, you can display 100,000 items, and there's no point to actually show off them because we as a human can't really see and understand it, and that's not much point. Make it actually a not very good visualization. Okay, and this is a summary of different the data types, data set types, and finally attribute types. So these are different data types, data set types, and finally the attribute types. Okay, and so these are just something you need to get take a little bit of time to get used to, and but I'm sure by the end of say in a few weeks, and you will become quite much more familiar with them as because we're going to using them in the lecture and lab as well. And okay, that's everything. So in terms of reading of the book, I already mentioned at the beginning of the lecture. So we covered the first chapter, why, visualization, and then the second chapter and about the data. It's called data abstraction, but essentially we mostly talk about different types of data. Okay, so that's the end of this part. So what I want to also do is actually show you the tools we're going to be using for the first coursework, which is called Tableau. And I have some slides of Tableau as well. And so we need to finish at 12 just to see if we have time to cover everything in terms of this part. And as I mentioned, and Tableau is one of the popular data visualization tools. And it is something you don't need to write any code. You can already create complex and interactive visualization. You probably know better understanding what interactive means now. And it's much more powerful than what you can do in, say, Excel spreadsheet. And you can create simple visualizations and in Excel, but usually they are not active. But in Tableaus, it can be much more complex and also be interactive. Okay, and that's the textbook we selected just to cover how to learn Tableau. Tableau, I say it has lots of functions, so in that sense can be quite complex, and also it has certain concepts, and once you understand them, it will start to work. But before you fully understand them, it might becomes a little bit difficult to use. So it might be slightly difficult to start with. And there's some books, and this is the one I picked for the module. And if you use some other resources, for example, online tutorials or videos, and if you think that's a better way, you use that, learn that way better, and it's completely fine. But we're gonna mostly follow this book. Okay, and so this is kind of like the starting page of Tableau, and that's what it looks like once you open the Tableau for the first time. So I can open my local version. So Tableau is updated every year. Actually, within each year, it has several different versions. And the one you see on screen is the version 0.3 for 2019. That's from last year, which was the latest version when I was creating the slides. So this is starting page. Okay. And this is my starting page. Looks slightly more complicated, and because I used something before, that's why I have a few extra things on there. And so this part is many different ways for you to connect to the data. So there are many things you can connect to. You can connect to Tableau server, you can connect to the file, or connect to other servers. And finally, they have a few existing examples come with the Tableau. Okay, and this is the start page button. So that's the button you can click and to go back to this page. So let me see if yeah. So for example, if I start some visualization, let's say I start this visualization, so that would look like this, and you will still have this button here. You can always click and it goes back to your start page if for any reason you want to go back there. Okay, and we're going to just have a quick look on this connection side. So you can connect to Tableau server, which is different product, which we'll not be using in this module. But say if a company is using Tableau, they probably have a server that everyone can connect to and share their visualization. And so the next part is a different type of files you can connect to. And this is probably what we're going to use the most. These has to be the files on your local computer. And it's probably quite small, but you can connect to the Excel spreadsheet and text files. Actually, so this is including the CSV, probably one of the most common types of data, which is the text file. And you can connect to JSON as well. PDF file will be slightly trickier, and some other files. Okay, and the next one is the different servers, but these are not the Tableau servers, but database servers. So you can connect to my Microsoft SQL server, you can connect to MySQL database, or Oracle, or even say cloud storage. The example shown here is Amazon Redshift, and it actually have much more type of server it supports. So if I connect it to the real version now, if I click more, you can see these are the many other different type of database it can support. And then so it's very, in a sense, it's quite powerful. Okay, and Tableau come up with some pre-existing examples data set. So these are the files that can load either as CSV or spreadsheet. So this is something we're going to do that in the lab later. Okay, and so this section is meant to show you the Tableau workbook that you opened before. And so the files you saved in the Tableau is called workbook. So that's the terms we're going to use. So essentially, these are just Tableau files. And if you opened Tableau files before, it's going to be shown here, something like a similar to other would be called, say, recent files in Microsoft Word or Excel. So because when you first open when you first open Tableau, this is probably empty, but once you start open a few books, as I did, then you will see some examples here. And I guess if you want, it's quite straightforward. You select the visualization you want to open and click Open Workbook. Okay, and here are some of the samples. So these are pre-created examples workbook by visualizing certain data, and you can use it to see what Tableau can do. So these are the ones usually quite complex. Okay, on this side, you can actually have some information online, which allows you to help you to learn Tableau. So the books we mentioned, the book I mentioned earlier is not here. These are mostly the ones provided by Tableau itself. So usually it goes to the website and it's either a document or some video. So for example, I think the first link goes to a video on the Tableau website. And you can play the video which shows you. Actually, we're going to go through that video a little bit later in the lab. Let's get back to the slides. And that's it. Okay, there's some extra information about the resource you can get. That's the start page. Okay. And then this is what the main interface of Tableau look like. Okay. It looks quite busy and it have lots of things. And I will try to explain. And obviously, it is completely okay. And if you don't really get to understand what each button or section, what each button does, or what each and part of the information means, that's completely fine. It can be slightly overwhelming at the beginning, but we'll make a start. So hopefully over time, you get more and more familiar with the interface. Okay. Maybe we'll start with the easiest one, which is the menu. It just on the top of the window, it just give you the access to different functions in Tableau. As we mentioned before, in Tableau, you don't need to write code, so all the different things you can do will be accessed through menu or some settings. That's all on the top. So for example, here, if I open up one of the example workbook, which is created by Tableau before. Okay. It's opening in a different window, which you can't really see. And we will just use the one which you can see now. And the menu is just these ones here on top. And just depends on what you choose. There's many different things you do. And also these changes depends on selection of data as well. But doing some just accessing the menu is the same as any other software. You can just click these to get the menu. Okay. And then the other part, the next part, is this side, which is quite important, which actually shows the data. Okay. So in this case, we're showing the data, and this top part, which is, and this part here, shows you the files that's being opened. And you can have multiple ones. In our case, we only have one. Maybe just look at this. And this part shows you different files you can open. So you can create a visualization that involves multiple files, get data from multiple files. Then you would have more than one listed here. And here it has three ones. And the first one called clipboard, the second one called the sample coffee chain, and the third one called the sample superstore. Okay. And so this listed all the files has been opened so far. Okay. And then this one, next one, is probably the most confusing one and maybe most important thing you need to understand about Tableau. This is about something they call dimensions, and this is something they call about measures. Okay. So sometimes it can be a little bit confusing to know what is dimensions and what is measures. But roughly speaking, dimensions is like the item we talked about, and the measures is like the attributes we talked about. Okay, if you remember, let me go back to just very quickly, and to go back to the previous set of slides. This one, yeah. Let me find the slides about the items and attributes. Okay, and so if you remember, the dimension is roughly, sorry. So these are called dimensions. Sorry, you probably can't see. It's roughly like the is roughly like the items in a table, and the measures is roughly like the attributes like table. Okay, and it's not a perfect match, but that's the closest thing I can find. And the details explanation, I don't really think it helps that much, but just try to remember like that.
So can we say this attribute thing is like the measurements, like the units which we measure the items in, like over there, when you connected it to the attributes over there, it was like temperature and everything.
Yeah, it's kind of like that. So I'm not sure if you can see, but for example, in the dimensions you have products, and then on the measurements part you can have the profit sales of different products, and similarly in the dimensions you have market, and then you can have say the sales, profit, or cost of each different market. That works for. But in that sense, say the market size would say probably should be a measurement of market, right? But still it's listed as a dimension here, which does not follow exactly the same rules. And the other things you will become more familiar with later on is you can actually change something, for example, market size between the dimension and the measure. And you can do this, you can change the type from market size from dimension to measure if you think that works better. And mostly the dimension and measure, it just depends on how Tableau would use it when trying to visualize the data. That's the main difference. Okay, and when you load a data set, Tableau would try to assign what is a dimension, what is measure automatically, and would try to automatically recognize the type. So for example here, it might be slightly difficult to see, but on the side you can see market, and before market it says ABC. So that means it's recognized as a text type of data. And the same for the here, it says ABC, and it says market size. And this probably should be number, but it's still recognized as a text data. And you have these little globes one, so that means it recognizes this as a location type of data.
Position maybe.
Yeah, just location or position means the same thing here. And then for the measures, you can all see this hashtag. That means it recognizes all these are numbers. Okay, so maybe in some cases we'll just treat all the hashtags as measures and everything else as dimensions. And for example, if you think market size and shouldn't be a text, it probably should be a number, maybe a number as well. Then it's something you can change as well. Okay, and you can create aggregations in Tableau, and for example, and you would have, let's say, the profit or sales of a product. That's you would have one for each individual product, and sometimes even one for each individual product for each transactions if they change. And then you can calculate many different things, and which it calls aggregations, or sometimes called measures. But these are the things, common things you can do: the sum, average, median, count, minimum, maximum, etc., etc. So now here it shows you a screen. You can calculate the different things if you want, and visualize the calculated results instead of the raw data. I'm sorry. And the next part is you can build visualizations in Tableau by dragging and dropping the dimensions and measures onto the visualization part. That's probably the most powerful thing in Tableau. Again, we're going to cover in more details later, but sometimes it's also a bit like the process kind of like a black box, opaque. You don't really understand exactly what will happen. And for example, I can create the code. Okay, so I would say first say this part is where you're actually creating the visualization, which you can see. So in this case, you can just create a new empty ones. So what you can do is you can drag and drop the data onto this pane. You can, for example, I want to see different countries, and I put it on maybe the x-axis. These are the different countries, and this is what happens when you drop it. And I want to see their, let's say, the BMI count, or let's say prevalence. I'm gonna put it on the y-axis. Oh, I can't do it here. Okay, so I have to put it here then. Okay, then it will automatically create the visualization for you. So what I did is I put the countries as a row, and which it calls columns, because each country is now a column, and each row or the y-axis shows and the prevalence is slightly difficult to see. Again, I don't know, it's possible to increase the text. So can you see the text at all?
Yes,
Yes,
sir.
So we can see.
prevalence of BMI.
Oh, okay. Yeah, that's good. I was a bit worried it might be too small. And so this is actually one of the data sets you're going to be using in the first coursework. And you might know BMI, that measures body weight index, which is basically measure whether you are overweight or not. And here it shows the percentage of the population in each country that are overweight. So some countries are much higher. But the way we created the visualization is by dropping the country onto the x-axis or the columns, and by dropping the prevalence onto the y-axis. And it's picked the bar chart, which you can change later on. But also here, the other thing I want to show is, if you can see, it automatically picked the SUM, which is add all the percentages together, because they actually have the values for each year, and it add everything together, which is not necessarily always makes sense. So you probably can change, you can change some, and then the measure, for example, change to average. Okay, and the shape doesn't really change that much, but what you can see now is now the values changed now to 0, 0.1, 0.2, all the way to 0.5. That much more sense. Say on average, for this country, which is American Samoa, has more than 50% population is overweight, but that's much more informative than the total we had before. Okay. And you can also change the type of the chart. For example, here, we're going to cover more later as well. So here is automatic, it's a bar chart. You can force it becomes a line chart, or force it to become an area chart. Just means you color the bottom part. You can show this inside the bar, each country as a circle, and etc. Yeah. So we're going to just keep, in this case, I think the bar chart is a good choice. You can clearly see what are the values for each country and compare them. Okay, and this is the example where you drop something onto, okay, that's the other thing. So you can either drop the value, you drag them, drop onto the X or the Y axis, or you can drop them here on the top, the columns and the rows. So the columns is the equivalent if you put it on the X axis, and the rows is equivalent if you put it on the Y axis. That's the same thing. You can put more, for example, I can put gender. You can actually put more than one in of these. So if I put gender onto the column as well, so you can see now for each country now have two bars. One is for men, the other one is for women. And the other thing I can also do is I can use, it's called sex. I put it onto color as well. So I say I want to use color to represent. Now you see, okay, now the man is blue, the woman is orange color. And for each country, we have two color and two rows, two columns, shows the values for the both gender. So that's the general way how you would create the visualization in Tableau. Okay, we're gonna have just to, because we're kind of running out of time. Okay, so this is something quite subtle, and you have slightly different colors when you have these values. The green one is continuous, like this, and the blue ones are discrete. That means it's like integers, 1, 2, 3, 4. In this case, like the gender is a man or woman, so it's not continuous. There's only two values. You can't have, say, 1.2 or 1.3 somewhere in between. Okay. Okay. And so for this one, just basically this one, you can have different pages, and we're going to cover that later. We don't have particular pages here, and you can filter data as well. You can create filters. For example, you don't want to show all the countries. You only want to show Asian countries, and you can create a filter here. Okay, and just because we are running out of time, we're going to stop there. And in terms of reading, and this is the first chapter or the Tableau book. So that's what was shown at the beginning of this second set of slides, and introducing Tableau desktop workspace. And then we're going to do more exercise about Tableau next week as well. So this week in the lab, we're going to present the results about the visual and non-visual analysis. And next week, we're going to do more exercise about Tableau in the lab. Okay, and that's it for today.